Alright, we're back again here for another problem with section 5.4 doing hypothesis test for two proportions. And you can see here we have a little bit different format. It says you wish to test the following claim. We have our null hypothesis, H sub A, at a significance level of alpha equals 0.01. So our null hypothesis here is that the P sub 1 is equal to P sub 2, and our alternate hypothesis, P sub 1 is not equal to P sub 2. And so this would be a case here where we have a two-tailed test. You obtain a sample from each of the two populations, and the distribution of successes and failures is reported in this contingency table. So we have this contingency table, and I'm going to try to copy and paste it over here into Excel. And let's see if paste special works. Well, got these guys moved over. I don't know if we can just drag them. Anyway, not too bad. Merge center here. So, I'm going to zoom in just a little bit. And remember our formula, we need to know these proportions here, P sub 1 and P sub 2. So we have successes and we have failures, so we need to get a total. And to do that, we can just use the sum function. And if I grab these two and then drag it over, we've got the sums now. Now I also need the proportions, so I'm going to just call those P, and we'll use the labels up above for the two. So if I take the success and divide by the total, I should be able to get the proportion here, and if I drag it over, I can get that again. Again, in the cells here, we're taking the proportion of the successes over the total for both columns, and the totals we found by summing up the successes and the failures. So we have to pay a bit of attention to the information we have to make sure we get these correct. And here I put the proportion here. This is P sub 1 and this is P sub 2. So a little different there than what we have. So P sub C, this is my pooled probability, and I want to sum up the successes. So I'm going to add these. I guess I could possibly use the sum function since they're stacked right next to each other. And then I have to add up n sub 1 and n sub 2. So taking the successes and adding them together, and taking the sum of the sample sizes and adding them together. And this is our pooled proportion, which we need to find our standard error. Now our standard error is the square root of, we have P sub C times 1 minus P sub C, and we multiply that by 1 over n sub 1 plus 1 over n sub 2, making it match our deal. And then I think I need another set of parentheses. Okay, so P sub C times 1 minus P sub C, 1 over this, 1 over that. That should be good for our pooled probability. Now it's a little bit more difficult to decipher what it is when we have all the cell numbers in there versus the numbers, but if we keep all the data in Excel and let it do all the rounding and all that stuff, we get the most precise answer that we can here. So my test stat is then P sub 1 minus P sub 2 divided by our standard error, and we need to get a p-value. So if I go to draw here, this proportions are normal, so I have the case here, and here is 0. My test statistic is over here, negative 2.32, and so it's this one, and because it's two-tailed, remember we have P sub 1 is not equal to P sub 2, we have to double the area in the tail. So this is possibly a point of confusion. One student's asked me about a little bit. You have to understand what's happening so that you can make sure you get your p-value right. So I can find the area to the left by doing a normal standard distribution, putting in my test statistic, hitting true, and then I have to double it because it's a two-tailed proportion. So here we are with our p-value, and somewhere in here at the very top we had alpha equal to 0.01. That's from right here. So we need to make a comparison of our p-value to alpha to make our decision. So in this case, our p-value is greater than alpha, so we will not reject the null hypothesis. So putting in the information here, my test statistic, negative 2.322, accurate to 3 decimal places, my p-value, 0.202, I missed a 0, get that in there. The p-value is greater than alpha, so now there's a bit of a trick thing here. The way that this works, we will either reject the null hypothesis or fail to reject the null hypothesis. So kind of going back to that court of law thing, we can say there is enough evidence or there is not enough evidence, but we can't really prove something did or didn't happen, or that's the idea here. So in this case, we fail to reject the null hypothesis. We reject the null hypothesis if our p-value is less than alpha. Otherwise, we fail to reject it. And in this case, if we fail to reject the null hypothesis, then there is not enough evidence to conclude that the proportions are different at this level. So there we go. One question walked through all the way. Again, we're doing our hypothesis testing for two proportions, and we have to use the data that we have. We're kind of given a table. We add to that to find the totals. We need the totals so that we can find our proportions for each one. Then we use our successes and our totals to find our pooled probability, using the pooled probability to find the standard error, taking the difference of those proportions, and then dividing by our standard error to find the test statistic, and then using the test statistic and the type of test we have for our alternate hypothesis here. Since this is two-tailed, we have the area to the left here, we double it, find our p-value, and then we use our p-value in comparison to our alpha to make a decision. So, quick little walkthrough. I hope that is helpful for you.